Hello everyone, thank you for joining us today at Hardware Pioneers Max. I'm Stacey and I'm a Product Evangelist at u-blox, and today I'll be talking about how to solve the complexity of communicating sensor data between IoT devices and the enterprise. So let's begin. It needs to be extremely easy to get data from IoT devices to the cloud, and what we find is that communication is much more than just the connectivity. Choosing the right protocol is key. And we will review the benefits today of MQTT-SN for IoT sensor applications and how to overcome the challenges of complexity, cost, and availability. And lastly, my colleague Mike Coombes will present a case study that is not about wind turbines, as the slide would have you believe, but instead about how social enterprise CompAir use our low-power MQTT Anywhere IoT Communication-as-a-Service to help solve the problem of poor air quality. Now, communicating data between the device and the enterprise is harder than you think. At first, it seems very easy. There's a device that needs to communicate important data, and there's a network, and you need some kind of cloud platform to receive and act upon that data. But if we take a closer look, it's not so simple. There are a lot of questions to be answered and complexities to be solved, such as what connectivity should we use? Which network should we use? How do we scale the solution? Is it secure? And what about power consumption or data allowance? Which interface or platform should we use? And what's the cost of all that when you put it all together? All of these calculations together need to be considered for a successful IoT deployment. When we consider real-world use cases, what emerges are certain characteristics that define the scope and range of the solutions used. Take into consideration applications such as condition monitoring, container tracking, pet tracking, and healthcare. For example, we need to think about the payload size, which may be as much as 500 bytes or even as small as 50 bytes. This, of course, depends on the application. We should also consider the message frequency, which may be infrequent, i.e. weekly or even monthly, or perhaps more frequently, say once a minute, for example. And with battery life, we could be looking at devices that charge once a week or even daily, and maybe even, in some cases, devices which are never charged at all, essentially a 5 to 10 year lifespan, the whole lifespan of the device. Many of these types of IoT use cases facing these constraints are going to need to use a low power, wide area network. These networks often have certain features such as power save mode and EDRX, that's extended discontinuous reception, which offer benefits of improved power consumption. However, the network operators themselves define the effectiveness of these features. And what emerges is that if you want fast, secure communication to the cloud, there's a major impact on battery life, and the choice of protocol really becomes an important decision. And choosing the right protocol is key. To demonstrate this, we like to use the analogy of packaging. Think of your data or payload as a message you want to send, and the protocol as the packaging or envelope that surrounds that message. As you can see, there are a wide range of sizes and flavors available for this packaging, which can be quite small, such as the envelope top left, which represents MQTT-SN, moving up to CoAP, which might be represented as a bubble wrap envelope, and over on the right, other protocols like HTTP feel more like a large cardboard box. Adding a security layer to that, such as HTTPS, makes it much more like a heavy-duty shipping crate, which, of course, you want that if you're sending a lot of stuff, but if you're just sending small IoT messages, you just don't need it. Again, in this constrained environment, we want to make the right protocol decision to be as efficient as possible. And so we lean more towards the left-hand side with protocols like MQTT and MQTT-SN. Why MQTT? MQTT, as you may or may not know, is a publish and subscribe protocol that is specifically designed for machine-to-machine communication. And it has the quality of service levels that are available that are specific to the requirements of the application. It's easy to use, it's reliable, it's very lightweight, and it's designed with scale in mind. And what is MQTT-SN? The SN stands for Sensor Networks, which means the protocol is specifically tailored for that kind of application. Like MQTT, from which it is derived, it's a publish and subscribe protocol, and as you can see in this diagram, there's a very important element here, and that is that the sensor values are published to topics. And that's important because it's worth knowing that the MQTT broker manages those topics. And on the right here, you see, sorry, I moved away from the mic. On the right here, you see that you have applications that subscribe to these topics. This publish and subscribe model becomes important because this is what's driving the efficiency. And a little more on that. With MQTT and subsequently MQTT-SN, don't think of it as a client and server relationship. You think of it more as client and broker. The client can be any device or thing that runs an MQTT library and connects to the broker. Clients don't message each other directly, but instead messages are published to MQTT topics, which are then managed by the broker. Clients can then subscribe to that broker to receive messages by subscribing to the appropriate topics. With the in this case, the broker acts like a signpost for the data rather than a storage system. The broker also handles authentication, manages connections, sessions, and subscriptions. The broker also queues messages and delivers them according to the appropriate level of quality of service. And now there are 3 levels of quality of service with MQTT and 4 for MQTT-SN, which introduces a completely blind fire and forget mode when it doesn't matter if every single message gets to the final destination. So let's go through a couple of ways this impacts the battery life. Going back to the packaging analogy, the smaller the overhead added by the packaging, the smaller the overall message size will be, and this translates to a longer battery life. And security also impacts battery life. Here we see a comparison of a typical track and trace application. On the left, using SSL or TLS, this uses 6 kilobytes in overhead, whereas secure end-to-end communication using MQTT-SN is only 26 bytes. A significant difference in the overhead contributes to power autonomy or battery longevity. Another way to think about this is about the actual time spent on air. Request and response protocols like CoAP, TCP on the left need more time on air to transact those requests and responses, whereas a publish and subscribe protocol such as MQTT-SN needs less time on air. Again, on-air time directly impacts battery longevity. Now let's see these statements in action with some data. Quite a lot of data, in fact, as you can see on these slides. So on the right, we have we see the number of bytes sent for just a simple hello world message, the payload of which is just 12 bytes. You can see very quickly in this graph that HTTP and HTTPS have a huge inflationary factor for the number of bytes that need to be sent over the air due to the overhead. On the left is a similar diagram that shows relative power consumption based on bearer and protocol. Again, the overhead introduced by the protocol impacts the power used to send the message. Why use up all your battery and data allowance on overhead when the value itself lies in the message? If you'd like more information on what we did to obtain this data, which was obtained in our own laboratory, come and see me afterwards and I'll show you how we went about that. Now I'll hand over to my colleague Mike Coombes from one of our customers, CompAir, who built a cost-effective, scalable air quality monitoring solution using our MQTT-based IoT Communication-as-a-Service. Over to you, Mike.
Cheers, Lee. Thanks, Lee. Hi, everyone. My name's Mike Coombes, and I'm a co-founder of a business called CompAir. It's nice to meet you, and I'll take my glasses off. I can actually see your faces. I can see there's quite a lot of who look like really clever people in the room, and I kind of like, in the interest of being transparent, I feel I need to let you know that I'm really not technical in any shape or form. And I also, interestingly, don't know an awful lot about air quality. So I'm not in a particularly strong place to be standing up here talking to you about technology or air quality, but nonetheless, I found myself. So what am I? I'm an entrepreneur at base, and my business partner, Guy, and I, we exited our business that we set up in the late 20s, which was involved in making Scion cases and then evolved into tech accessories. And we exited that business a couple of years ago. And the business's environmental credentials weren't particularly fantastic. And after a couple of life-changing kind of experiences and moments, we decided to set up a social enterprise called CompAir, which is all about trying to inform and educate people about the dangers of air quality. And our tagline is making the invisible visible, because most of the poor air that you breathe is completely invisible. Right, so here we go. Let's see if this works. So, air pollution. According to the World Health Organization, air pollution is among the top 5 risk factors for premature deaths globally. Many of the drivers of air pollution, for example, combustion of fossil fuels, are also sources of greenhouse gas emissions. So, policies to reduce air pollution offer a win-win strategy for both climate and health. The problem is made even more challenging because, as I previously said, most of the air pollution that we breathe in is invisible, even when it's at dangerous levels. So it just says here, 7 million deaths is what the estimate is. And every day, and I'm obviously very sensitive to it, every day I just hear more and more bad news just about how bad the impact of air quality is on health. It increases the likelihood of strokes, heart disease, lung cancer, chronic, and that's just a few of them. Okay, so CompAir, we're a social enterprise on a mission to empower business to see and take action on poor air quality. Working with UCL, when we first started, we've developed a cost-effective, easy-to-deploy, real-time monitoring technology that aims to build awareness and, at the same time, safeguard communities. Poor air quality affects nearly everyone in the world. The big question is, how do a few know not a lot, which is me, my business partner, etc., how do we make a start to improve such an enormous global problem? Well, you have to start somewhere. So what we did, we picked 2 sectors which we thought we could perhaps make a difference. And in the first instance, it was construction. Construction creates some amazing buildings, but in the process, it creates an awful lot of poor air. So on this image, you'll see, that's me installing one of our devices, which looks like that, if you get an idea of the scale of it. So, CompAir answers the challenge with Air Tracker. It's a small, portable air pollution monitor that uses precision laser optical technology to examine air. The Air Tracker can detect key airborne pollutants, including particulate matter, 2.5 and 10. I'll come on to a little bit more about that. Nitrogen dioxide, NO2, carbon dioxide, CO2, and volatile organic compounds, VOCs. And a lot of these nasties are all emitted from plant machinery and construction activities. So here we are with our construction. So this slide shows that we've got currently four sites around the UK on big construction sites with 4 to 8 air trackers per site. And when we put this slide together, and it'll be a lot bit bigger now, we've taken over 3 million samples. So if you think 3 million samples multiplied by the number of pollutants that we're measuring, that's already an enormous amount of samples or amount of data. And with that data, we're already getting insights, and we're helping to safeguard workers and communities. So this is just one example, and I just don't want to go into a lot of detail about the site, the type of thing, but this is one site where we had 3 air trackers in 3 places, and you can quite see that this orangey line is suffering from much higher pollution. And so using that, we can then send a text message to the construction site manager who can look at that Leadenhall South cabin and work out what's going on. So we're able to give fairly real-time data and information and insight about what's going on the construction site. So one of the second areas that we decided sectors to look at in terms of what we can improve is social housing. Inside air is really, really different to outside air. And quite often you find that the air inside is actually worse for you than the air outside under certain circumstances. And so by placing these monitors inside people's homes, we're already getting quite good insight into what's life like for residents, how safe the property is, and whether the heating and ventilation performance is working okay. Quite often you find that social housing is occupied by elderly people. Elderly people quite often have health issues that are made worse by poor air. So here's just one example. So this line here at the 100 micrograms, so this is PM 2.5. So to give you just an explanation about PM 2.5 really quickly is particulate matter. They're tiny, tiny particles that are 2.5 microns or less. A human hair is 60 microns. So this is about a 20th of the size of a human hair. You can breathe them in, they go into your bloodstream and potentially stay there. It's really, really dangerous. And the world's most populated city in India is running at an average micrograms per cubic metre of this fine dust of 100. And this is inside a bungalow in Sunderland in South Wales Close across 3 days. And if you look at the line, you can see that when the resident is awake, when they're asleep, nothing's going on. So there's very low PM levels when they're asleep. When they're awake, something's going on. And a lot of that's to do with cooking, not having extraction, not switching the extraction on, not knowing to switch or not knowing to open the windows. And so there are really genuinely just practical steps that we could give residents and inform people in order to reduce their air quality. And that's just one example of of how you can give people insight. So that's what I was going to show to you really today. 2 examples, construction and some social housing. And it's been very helpful working with these guys who have helped us put together the technical know-how to be able to do it. Because I genuinely, when I watched that explanation, I didn't really understand any of it at all, like none of it. And so it kind of says something that you can work with these guys and that we can actually deliver this product that's actually creating insight without actually knowing anything about the technology that's going on it at all. Yeah. So anyway, so thank you.
Thank you. So what's in the box that enables this? As you can see, that's not actually the box that Mike was holding. It's a similar kind of device. Alongside the cellular modem is a u-blox MQTT Anywhere SIM card that provides access to our IoT Communication-as-a-Service solution. And that's what allows CompAir to get the data from these air quality devices to the cloud. To summarize what this gives you, the IoT SIM card gives you access to over 600 cellular networks in 190 countries around the world. So that's most of the world. It also gives you access to our MQTT-SN gateway, which enables efficient communication. And also access to our enterprise-grade MQTT broker and auto-scaling technology. With that, you also get predictable pricing, which, unlike a lot of solutions, isn't based on the amount of data you send, which is a cost that can escalate and can be a bit, how much is it going to cost? Instead, we charge per message, and we bill by the number of messages sent per month. With this, the customer then has complete visibility and understanding and predictability where cost is concerned. Now, if you cast your mind back to the beginning of my presentation, with the diagram with all the question marks on it, this slide shows how all of those questions are answered by our solution, including all of the hidden ones that you might not think about. and that's it, and that's the job done in that case. So to conclude and wrap up, we've seen that the connectivity is only part of the overall low-power solution, and that choosing the right protocol is a major factor and a very important decision. And we at u-blox offer a whole suite of IoT communication solutions that utilize MQTT, allowing customers to solve that device-to-enterprise challenge. If you'd like more information on our IoT Communication-as-a-Service or would like to try it out for yourself, come and see me at stand 38 and we can have a chat. Thank you very much.